2a. Okay, so this is the initial point. Okay, this is the initial end point or the final. Okay, so at the initial point u, which is the initial velocity, at this point here, the initial velocity is -6 meter per second. Okay, t is 0. Okay, at the initial point, and then at the initial point is given that displacement equal to -50. Okay, at t0, displacement equal to -50. So usually for initial, we put as S0. Okay, S0 means initial displacement. Okay, U represent the initial velocity. Okay, so at the point A here, the V, at this point, V, which is the final velocity for this section 1, V is equal to here. So V is 0. Okay, the time here is 3.75 seconds. Okay, the displacement A is unknown. Okay, and then the acceleration AO is also unknown. Okay, so now you have three equations, which is V is equal to U plus AT, V squared is equal to U squared plus 2A S minus S naught, and then you have here is S minus S naught is equal to UT plus half AT squared. So this is three equations that you can use for the constant acceleration analysis. Okay, so for the first case, you need to, for the first section, the unknowns that you need to determine is acceleration and also the displacement. Okay, so from the known parameter, which is initial velocity, final velocity, initial displacement, and also the time difference, you can use this equation, okay, to get acceleration first. Okay, so then you get 1.6 meter per second squared. Okay, then your second objective to determine the final or SA. Okay, so it's actually you can use it's better to use this equation, okay, because you know V, you know U, and also acceleration and the initial displacement. Okay, so if you substitute the value into this equation, you get this is your SA. Okay, displacement at this point A. Okay, okay. So for then you go for section AB. Okay, section AB. Why do you need to determine acceleration and displacement? Okay, because from here, from an acceleration and displacement value, you can draw a graph profile, which is acceleration against time profile, and also displacement against time graph profile. So that's why in this analysis, we find acceleration and displacement. Okay, and then after we finish the first section, we go on the second section, which is section A to B. So now point A will become initial point and B will become the final. Okay, here is O is the initial and A is the final. So at this initial, so at point A will become your initial velocity, at point B will become your final velocity, and also this would be your S naught, and here it should be your SB. Okay, so initial velocity is VA, at point A is 0, and V final velocity is VB, 10 meter per second. And then you don't know what would be the acceleration, you need to determine here. And then S naught now is your SA, you already calculate here, okay? And then SB is unknown, and you have the time difference, 6.25, okay? Please remember, this time here represent the time difference, okay, between final and the initial position. Okay, please make sure this is a time difference. Alright, so now you already list all the important parameters, so you can substitute into this equation. Okay, into this equation. So you obtain acceleration is 1.6 for section AB, and for SD is negative 30 meter. Okay, so now you obtain two parameters, acceleration and displacement. Then you go on the third section, B to C. So point B now will become your initial, and point C will become your final. Okay, so initial here is U, S0, here will be V and SC. Okay, so you list all the parameters that you know. So here is the initial, here is the final. So initial here is VB is equal to 10, VC also 10 because it's a constant velocity, and then acceleration is zero, is unknown. So SB you already calculate here, and SC is unknown, and the time difference is 5 seconds. 15 minus with 10. Okay, so you input into this equation, you will get acceleration 0. Okay, because from here you already know that constant velocity acceleration 0. And then you can use this equation. Why in this kind of section it use this equation? Because acceleration is 0, so means that all of this thing will become 0. So it will ease your calculation. Okay, so you just have this for the calculation, which is SC is equal to 20 meter. Okay, here is 0. Okay, any question so far? Ada soalan apa-apa?
Sir,
Yes?
saya tak ikut sir.
Oh, yeah, very good.
Okay, sir.
Alright. Ada lagi soalan? Okay, so we finish for section B to C, and then we go on section fourth section. Okay, from C to D. C to D. So now your C is become the initial, and your D is become your final. So you list all the parameters that you know. So at C is V equal to 10, which is U initial 10 meter per second. And at this point, you know that V should be equal to 0. Okay. And then at this point, SC is 20. Okay, and the time difference here, 25 minus 15 is equal to 10 seconds. Okay, so you substitute into the equation, then you get acceleration is -1. Okay, why -1? So from here you know that this is a negative slope or negative gradient. Okay, so that's why you get acceleration -1. Okay, so usually from the answer you can check. Okay, you can check by referring to the graph. Either is make sense or not. Okay, and then you find the uh, displacement at point D. So here should be ST. Okay, which is 70 meters. Okay, so when you do the analysis from section 1 to section 4, 1, 2, 3, and 4 is actually you already answer question A, question B, and question C. Okay, so for the distance travel, since during the calculation you already include this OA, AB, which is this point here, so means that you know the information here. The information where the particle change direction, which is V equal to 0. Okay, so you know that at 0, at time equal to 0, your S0 is equal to negative 50 meter. Okay, and then t equal to 3.75 seconds, then your SA is equal to negative 61.25. So you list everything, then you put it in a lines, displacement lines like this. Okay, and then you have t equal to 10 seconds, then you get SB is equal to negative 30 meter, and then t equal to 15 seconds, then you get SC is equal to 20 meter, and then t equal to 25 seconds, then you get SE equal to 70 meter. Okay, so what you have to do, you draw this displacement line, and then you know that at this point here is a change direction, so then you can determine the total distance travel. So from this point here is 11.25, and then you have another 11.25, and then plus 50 and plus 70. Okay, it's up to you on how you want to calculate this distance. Okay, usually I will use this, and then I just directly use this one, which is at 11.25 plus with 61.25 plus with 70. So usually I will do like this. Okay, but the answer is still the same. Okay, it's up to you how to calculate this total distance traveled. Okay, so this is for question D, and then we go on question E. So for question E is located at between 10 to 15. Okay, so for question E, this would be uh, the the line. So here is 12. Okay, so now this is your initial point. Okay, initial point here, U. So here U equals to 10 meter per second. Okay, at this point also the V is equal to 10 meter per second. The time difference is 12 minus 10, which is 2 seconds. Okay, and then the SB, you know that SB is equal to negative 30 meter. Okay, now you need to determine what would be the S at 12 seconds. Okay, here also you know that from 10 to 12 the acceleration is 0. Okay, the acceleration is 0 because it's constant velocity. Okay, so you just substitute into this equation to get this S, which is it used as SE or S12. Okay, and then here is 0 everything, then you get SE equal to negative 10 meters. Okay, so any questions so far? Okay, so I hope everyone can look back into this example. Okay, basically you have three ways. First, you use the equation of the line. The second one, you use area under the graph, and the third one is you do on the, if the case is constant acceleration, then you use this equation. Please make sure which method that you need to use. Okay. Alright, so for this exercise, I will let all of you do that. Basically, it's the same as the previous example because you have V against T graph. Okay, so you just need to change V against T to displacement and also to the acceleration profile graph. Okay, basically it's the same. So what I will do today is on the exercise 2.19 here. Okay, I just add this exercise. Okay, so for this exercise, it's swimmers. You have two swimmers, A and B, leave the starting block at the same time. Okay, so swimmer A accelerates at 0.3 meter per second squared for the first 10 seconds, then maintains his speed. Okay, swimmer B accelerate at 0.5 meter per second squared until reaching a maximum speed of 5.5 meter per second. He then maintained his speed. Okay, so the question is plot AT, VT and ST graph for each swimmer from T equal to 0 to T equal to 15 seconds. And B determine the distance between the two swimmers when T equal to 15 seconds. Okay, so usually when you deal with these kinds of topics, okay, you will face the question that there is no graph, there is no equation. Okay, like this exercise. Okay, you have only a sentence where you need to understand the sentence and you need to draw all the graph. Okay, so first you need to understand the question. Okay, here, let's say if I, I do on the swimmer A. Okay, so swimmer A, so let's say here is swimmer A, and then here I have swimmer B. Okay, so in the question it's mentioned that accelerate at 0.3 meter per second squared. So I will do on the acceleration against T graph first. Okay, with the information given. So acceleration meter per second squared and time is second. Okay, it's mentioned that, so we assume that it starts from 0. Okay, because for the swimmer it's usually start from rest. Okay, so it start from 0, then okay, it accelerate 0.3 meter per second squared for the first 10 seconds. So accelerate, it's mentioned 0.3, okay, for 10 seconds. 10 seconds, and then maintain his speed. Maintain his speed means that constant velocity. Maintain his speed means that it's a constant velocity. So after 10 seconds, the swimmer A maintain his speed. So constant velocity, then you will have zero acceleration. Okay, zero acceleration. So in the question it's mentioned that the swim for 15 seconds. So we know that the end point, the time here should be 15 seconds. Okay, this one is for swimmer A. Okay, we have this kind of graph, 0.3 meter per second square acceleration. After 10 seconds, maintain his speed. Okay, then we go on swimmer B. Okay, acceleration meter per second squared. Okay, so for swimmer B, it's mentioned that accelerate at 0.5 meter 0.45 meter per second squared until reaching a maximum speed of 5.5 meter per second. Okay, so now you don't have on swimmer B, you don't have the information where the time swimmer B stop accelerating, but then it provide the maximum speed here. Okay, first you can just draw the acceleration, which means here is 0.45, and then at the certain time, which is the unknown, so you don't know what is the time here, then it will maintain his speed. So the end time here is 15. Okay, so this is the acceleration graph for both swimmer A and B. Okay, but then for swimmer B, you still have the unknown here, which is the time. Okay, so then we go on V against T graph. Okay, V against T graph for both swimmer. Okay, and here should be V meter per second, V meter per second, then here is time. Okay, so here you have only 0.3, okay, 0.3 0.3 meter per second squared. Okay, so we know that both swimmer will start from zero velocity. Okay. Okay, so if you have a constant acceleration like this, then you will have a graph which is positive gradient because you have positive acceleration. So you have positive gradient graph. Okay, and then you have a zero acceleration, means that is a constant velocity. Here is 10, here is 15. So the the equation here, you can determine the equation here, which means that you know that V equal to mt plus C. So since we assume that the swimmer is start from rest or is initially not moving, so we say that it start from zero. So the y-intercept here will become 0. So you have V equal to mt. So the gradient of the velocity graph is actually the m here, which is v equal to 0.3 c. Okay, for this line. Okay, so now you can determine what would be the velocity here. So the velocity here as time equal to 10, which is equal to v 0.3 times with 10. V equal 0.3 times with 10 second, then you will get here is 3 meter per second. Okay, for the velocity here. Okay, so this is V against T graph for swimmer A. Okay, and then you go for swimmer B. In the swimmer B, it's mentioned that it's reaching a maximum speed at 5.5 meter per second squared. So means that this is the acceleration 0.45. So the maximum here is 5.5. So here should be your graph. Okay, 5.5 meter per second, and then it's maintain speed until 15 seconds. So 15, so here still unknown. Okay, time. Okay, so you know that the gradient of the VT graph, the gradient here is actually the acceleration. Okay, the gradient of this graph is actually the acceleration here. Okay, so you know that the equation of the gradient, which means that if you learn from the secondary school, which means gradient is equal to y2 minus y1 over x2 minus x1. Okay, so which means that this point here, which is 5, which is t, and 5.5, here is 0 and 0. Okay, time 0, velocity 0. Okay, this is time, this is v. So if we change y to v2 minus v1, t2 minus t1. So the gradient here is actually the value of the acceleration. Okay, so 0.45, v2 is 5.5, v1 is 0, t2 is 0, t2 is unknown. Okay, the t here, so t minus is 0. Then you get the t here is 12.222 seconds. So basically the t here is actually 12.222 seconds. Okay, so any questions? Ada soalan tak? Hingga sekarang. Any questions so far?
No, sir.
Boleh ikut Okey. Okay, so then we will draw a graph which is S against T, which is the displacement graph for both swimmer A and swimmer B. Okay, this one is S meter. One is displacement. Okay. Alright, so you know that the equation of this graph is actually v equal to 0.3t, and then the equation of this line is actually v equal to 3 meter per second. Okay, so now you need to draw displacement against the graph. So here is 10, here is 15. Okay, so for the first section here, this is the first, this is the second one. So the first section, you know that integration of displacement, which is from 0 to t, 0 to s, is equal to 0.3t dt from 0 to t. Okay. Here you have, if you integrate, you get s from 0 to s is equal to 0.3 t squared over 2 from 0 to t. And then you will get the equation, which is s equal to 0.3 t squared over 2. Okay. Get here is s equal to 0.3 squared over 2. So at time 0 here, the displacement will be 0. If you substitute time 0, your displacement will be 0. If you substitute the time 10 here into this equation, you will get your displacement equal to 15. Okay, 15. So since this is a positive gradient, so it will look like a smile shape. Okay, smile shape. Okay. Alright, so for the second section here is v equal to 3 meter per second. So second section, we'll still do the same integration from now is from 15 to s, because you know that this section here, which is 15 meter, for displacement ds is equal to, the time is 10 t v3 dt. Okay, the v here is 3. So if you integrate, you get s minus 15 equal to 3t minus with 30. Okay, if you rearrange the equation, you will get s is equal to 3t minus with 15. Okay, this is for the second section. So if you substitute the value 15 here, okay, you will get is 30. Okay, 30. Okay, if you integrate constant, you will get a positive, if you integrate positive constant, then you will get a positive gradient line. Okay, so it's actually, if I can redraw it. Okay, so this is your displacement against T graph. So you know that at this time, the displacement is 30 meters. Okay, where you substitute 15 seconds into this equation. Okay, 3 times 15 is 45. 45 minus 15 is 30 meters. Okay, so now you go on the second graph. Okay, the second graph is swimmer B. Okay, so for swimmer B, is the time 12 to 2. This is the final position 15. Okay, so you still need to do the same thing. So the first section and the second section. So the first section is just V equal to 0.45 T. So this is the first section. So you do integration from 0 to S. ds is equal to from 0 to T 0.45 T dt. So if you integrate this one, you will get S is equal to 0.45 T squared over 2. Okay, so if you substitute this value into this equation, then you will get 33.61. Okay, you will get 33.61 for the displacement. So since here is a positive gradient, so you will get a smile shape quadratic graph. Okay, and then you go on the second section, you integrate the constant. So second section, you get integration of displacement is 33.61 to S ds equal to okay, all right. Then from T here is 12.22, the lower limit, and V is the V here is this constant 5.5 dt. Okay, if you integrate this one, you get S minus 33.61 equal to 5.5 T minus with minus with okay, just give the final equation. Okay, you can directly calculate this one. So S is equal to 5.5 T minus with 33.61. Okay, so first you need to integrate ds, which means that you get S. So S for the left hand side is S minus 33.61 and equal to, for the right hand side, 5.5T minus 5.5 times with 12.222. Okay, if I can put here, if you integrate this one, you get S minus 33.61 equal to 5.5T minus 5.5 times with 12.222. Okay, if you solve this one, you will get this equation for the second section. Okay, so what you have to do, this is your general equation. So you substitute 15 into this equation. Okay, then you will get the displacement is actually 48.888. So at this point. So you know that if you integrate this constant line, you will get this positive constant, then you get a positive gradient graph. Okay, first order of the line. Okay, so this would be your displacement against T graph for swimmer B. This would be your displacement against T graph for swimmer A. Okay, please make sure this is a second order, which is a quadratic. This is the first order. Okay, so you solve for question A, where you need to plot A against T graph, V against T graph, and displacement against T graph for T from 0 to 15 seconds. And then the question asks you determine the distance between the two swimmers when T equal to 15 seconds. Okay, so you know that at T equal to 15, swimmer A is 50 meter. Okay, T A equal to 15 seconds. Swimmer A is 30 meter. Swimmer B, 15 seconds. The displacement is 48.888. 48.888 meter. So it's mentioned that the distance between the two, so you just SA SB minus with SA, which is 48.888 minus with 30 meter. Okay, the distance between swimmer. Then you get 18.88 meters. Okay, so usually the questions will look like this. So you need to understand the question, and from the question you need to draw the graph profile. Okay, so any question? Ada soalan? Ada soalan ke?
Sir,
Yes,
can I use the area under the graph to calculate the distance?
yes, you can use under the VT graph.
Okay, sir.
Usually under the VT graph you get displacement, and then the difference between displacement swimmer A and swimmer B, then you will get uh, the difference distance between swimmer A and swimmer B. Okay, ada soalan lagi? Any question? Okay, so far okay.
Sir, sir,
Yes,
hello.
yes.
So can we use the formula to calculate,
Formula of what?
to calculate the distance or the acceleration?
Which formula?
Uh, S is equal to ut plus half at square.
S equal to ut plus half at squared. Yes, you can use that because this is a constant acceleration, but then you need to know the parameters. Okay, you still need to use the graph. Okay, you still need to use you still need to draw the graph. Then from the graph you determine the initial and final parameters to use that equation. Okay, is in order to use that equation, which is the special case for constant acceleration, you need to understand either this problem is constant acceleration or not. Okay,
Okay, thank you.
any other question? Okay, so for the actually for this slide, I put a past year question. Okay, so to introduce to all of you how the question in the test will look like. Okay, so this is the example of the past year question. So if you notice from the question, you don't have a figure or you don't have a graph. So you need to understand the question and then you need to start to draw the graph, okay, based on the question, based on the sentence. Okay, so if you notice here, a particle start at the point A is moving along a straight path. Okay, straight path means rectilinear motion, which is this chapter, chapter 2, you learn on rectilinear motion. So with velocity given by v equal to 3t minus 4. Okay, for the 6 seconds. Okay, and continue with a constant velocity for 5 seconds and continues with a constant deceleration for 3 seconds until stop at point B. Okay, at t equal to 0 seconds, the displacement of particle is 0. Okay, so now from this example, okay, I just give you the clue for of how to answer this question. So I will let all of you do this. Okay, I want all of you do this past year question. Okay, and you need to think, okay, of how to solve this one. Okay, so here you need to understand this equation. This is v equal to 3t minus 4. So you know that if y equal to mx plus c, so this is the gradient, this is the y-intercept. So v equal to 3t minus 4. So you know that the y-intercept is negative 4 and the gradient is 3 for 6 seconds. So if you draw the graph, then you need to refer this line, the line equation for the 6 seconds. And then it's continue with constant velocity. Constant velocity means that velocity against t graph is on a just a constant value. Okay, no gradient for 5 seconds. And then it's continue with constant deceleration. Okay, if accelerate, you have a positive gradient. If decelerate, you have a negative gradient of the VT graph. Okay, and until stop at point B. So stop means that the velocity at point B will equal to 0. Okay, so at t equal to 0, displacement of the particle is 0. Okay, so I think this is the clue for this question. If you know to draw the one of the graph, which is v against t graph, then you can solve everything. Okay, so this is the clue for this question. I hope everyone try to do this past year question. Okay, any questions so far?
No, sir.
Doctor,
Yes.
for this question, it's just as similar as the just now question, right?
Just now, or previously, this question you
Yeah,
don't
previous.
have the equation.
Yeah.
Yeah, it's actually the same. You need to draw from the center. Okay, any other question before we end the class? Okay, so if you don't have the questions, so please try to do this past year question, and also try to do this example. Basically, it's just a straightforward example here. Okay, you can refer to the example in this slide. Okay, so I think that's all for today. Thank you very much. So for those who not yet scan your attendance, please do so. And for the rest, if you don't have any question, you may leave the class. Thank you very much and have a good day, everyone. Assalamualaikum.
Waalaikumsalam. Thank you, sir.
Thank you, Doctor.
Record the test. Are you still there?
Yes, yes.
Doctor, can you look at the question 2.6, the ping one question?
0.6. Why?
2.6. The question one with the answer. I'm just want to know the method that must use in that question.
Exercise 2.6.
Uh,
Exercise Betul, exercise.
dia bukan exercise. Dia yang kat bawah yang colour pink tu. Exercise kot tak tahu. Yang question punya.
Yang particle move from rest at A to point C tu ke?
Yang tu.
Okay.
Saya just nak tahu method sebab saya dah try yang graph pun sebab dia first kan dia bagi dalam minit kan. Saya dah tukar dah dalam second.
Dah tukar
Lepas
dapat
tu
apa? Dapat berapa second?
saya dapat 1/1200 T.